Image2 takes as input the rate file that we just created from level 1. The output are _cal.fits files. So these are calibrated subfiles. And by that we mean that the units have been changed to megajanskis per steradian for imaging mode, rather than dn per second. And then another output is going to be the I2D file. And so this is the file, like Carl mentioned, that's gone through the resample step to have the distortion removed. And this is, remember, this is not used later in the pipeline. This I2D file is basically just for you to look at your data and make sure everything looks as you expect. We've got the same resource and documentation links here, the same installation and reference files notes for if you run the notebook locally later. Let's start by importing packages we need. And we're going to import the JWEBImage2 pipeline along with all the various steps. And we're still using import 2.0. Let's come down here and again define output directory and then just a couple of convenience functions. Then we'll download some sample data to play with. So in this case, we're going to download 3 different rate files, one of which you'll already have if you've run through the Detector1 notebook. We'll download an association file and have a look at that, and a parameter reference file. And then just like before, there's also a set of mirror data that you can download, and as well as a mirror association file in order to run the exercise in this notebook, which we're also going to skip. I just mentioned association files. So these are basically JSON formatted files that contain a list of exposures, a list of files. And so the advantage of this is that you can actually feed these association files into the various pipelines, and the pipeline will go off and process all of the files listed within there. So these association files are kind of just an easy way to keep things organized. And especially as you get into more complex situations where you have, say, background exposures that need to be subtracted or things like that, those can all be organized within an association file. Let's just take a quick look at this association file we downloaded. You can see in here the important things to note. There's this ASN rule, which is DMS level 2 B base. And this is important because the stage 2 and stage 3 pipelines both can use association files, but they're organized in slightly different ways. So you have to make sure you're using the right organization, the right set of rules for the right pipeline. So in this case, we're on stage 2 and we're using this level 2 B base. And then down here we've got products, and within products it's essentially a list here showing our 3 rate files that we just downloaded. And so now you can call the pipeline with this association file, and it will go through and just process these 3 files one at a time. As before, we've got the run, the call, and the st run methods for calling the pipeline. So we'll look at that a little bit as we call the pipeline down below. So let's first look at this parameter reference file that we downloaded. So I've mentioned them before. These files that they're ASDF format. It's just a way to capture parameters and their values for various steps and pipelines. So it's ASDF format, so you can use the ASDF package to open it, and then you can use .tree or also .infoworks to look at the contents. And so within here, you can see there's a bunch of metadata about this file itself. More important here, we've got the name field, which describes. It says that this parameter reference file is for the Image2 pipeline. Here in parameters, we've got the pipeline-specific parameters, so save results is set to true. And then we've got steps, and within steps we have a list of pipeline steps. So here we've got the background step. And then within the background step, there's a parameters field also, and that lists the background step specific parameters and what those are being set to. So in this case, skip is being set to true because in general, by default, for near-cam imaging, you're going to skip the background subtraction step. And here we see next in the list, we've got the resample step, and its skip is set to false, and extract is set to 1. And don't forget to close the file after you're done looking at it. So this is just kind of a convenient way to organize your parameters. And it's personal preference whether you keep the parameters and their values here in this file, or if you do use the run method and you keep them within your Python code itself. So let's then move on. Like I mentioned before, the output of this pipeline is going to be the cal files, which are calibrated SOAP images, and then I2D, which are the rectified calibrated SOAP images. So let's run this pipeline first with the run method. And so in stage 2, there aren't a whole lot of parameters to play with, but just for fun, just so that we have a record here, let's look at the resample step, and we'll use this .spec attribute again. You can see we've got a list of parameters we can play with. Track is the one that we'll try setting below. So just like with Detector1, with the run method, we first create an instance of the Image2 pipeline. We'll set the pipeline specific parameters. So we'll set save results equal to true. We'll set the output directory to be the directory that we defined above. We will set this resample.extract equal to 1, even though that's the default, just to show you how to set parameters. And then in this case, we have the association file rather than a single fixed file. So we do image2.run, and we provide the name of the association file. So that'll go off and run. That's a little bit quicker than the Detector1 pipeline. But in the meantime, just like before, if you wanted to use the call method with this, so here you've got the Image2 pipeline, and you're doing .call, provide the association file, the pipeline-specific parameters, and then again the config file, and you set it equal to that parameter reference file that we just looked at. Or if you don't have that file, here's the, just like before, the nested dictionary. And so you can here supply that as steps that this parameter dict. And so you'll notice in this call, I'm actually giving the parameter reference file and this nested dictionary, which is totally fine, but you have to be a little bit careful if you have the same parameter defined in both places. Then you need to be aware of kind of the hierarchy of where the pipeline is going to get the value from, which one it's going to use. And so there, read the docs documentation, it goes into that a little bit. I think in this case, the parameter dict will win out over the parameter reference file. Similarly, from the command line, strun, you give the name of the Image2 pipeline, you can give it the association, name of the association file, and then here we're setting the step-specific parameter, the resample parameter extract. Or if you want to use the parameter reference file, then it's just strun, the parameter reference file, and then the association file, and that's it. So let's go up here and see. Yep, it's done. So again, the log is similar to the last one. If you go down to the bottom, you'll see now we had our inputs were the three rate files listed in the association file. And so here you can see that it saved the results into 3 cal.fix files. So let's down here, and we'll take these files. I'm going to grab the input names from the association file, but you can grab them however is convenient for you. And then the output files And what I'm doing here is I'm just searching the directory for any cal.fits file. Here's our list of 3. Oh, I'm going to use AstroPy to open this instead of data models. And so what I want to do here is just use the info attribute just to look at the file structure of this. And so you'll see in this case, if you were to compare this to an uncal file, or to the rate file, we now have this area extension, which is a pixel area map, a relative pixel area map that's been imported. And we also have 3 different variance planes, which have been added and added to the 3 various steps. And so these have been added in by the various steps of the pipeline as it is working. We'll just take a quick look. So we'll look here. We're looking at the science extension at the header. So print that out, and then just to show a little more information that's been added during this pipeline. So you can see the units now are megajST per steradian because we've gone through the flux calibration step. We've got a few different photometry-related keywords here. We've got pixel area in a couple different units, and then some flux density conversion factors. And also we've got, now here's the WCS. So the full WCS, the JWST that Carl mentioned, is stored here in this ASTF extension of the file. But here in the science extension, there is a WCS put in here. And what this is basically an approximation of the JWCS. And so this is in here just so that if you use DS9 or something like that to open up a cal file, it will render and look decent. It should be accurate to some fraction of a pixel, but it won't be exact. So then let's look also at this I2D file. Remember, this is the one that's gone through the resample step. So distortion has been removed. Get the data from that. Just to look at the difference. So first, we'll show the cal file. So this is the one that has not been resampled. And so here we go, our 2K by 2K detector. It's not stretched quite as hard as the rate file in the other notebook, so it looks a little different. And for comparison, let's look at this I2D image. Here you see in this resampled image, we've got some bare edges here because the distortion has been removed, so things have shifted a bit.